Hello everyone, my name is Sumit Gaur from Impulse Technology, Delhi, Gurgaon. Today in this video, we will demonstrate the thermoelectric properties of materials. First we have to go on our device studio user interface. As you all know, as you can all see, our this is the device user interface in which our project name is thermoelectric property. First, we have to create a structure, material structure. So I will go on for the making the structure. So go to the build option and click on graphene nano ribbon, and as you can all see, this is the graphene nano ribbon pop-up window is shown here, and which you can select the crawl vectors and and M. And after doing this, you can, if you wanted to change their carbon atom, or like if you wanted to change their element, you can change from here. Now I will select this value will be 0 and 4. Now click on preview. Now this is our structure. So I will click on build option. Okay. Now you wanted to see this structure in different view. You can, there is a 3D viewer option, and you can select it from like this. Okay. Now we have to expand it into expand this structure. So go to the build option and click redefine, and I will select this value 5 and click preview and click build. Now this is our structure which we have to perform the calculations for thermoelectric properties. So now the next thing is we have to create the SCF input for this structure. That is, now we have to go to the simulator, NanoDCAL, SCF calculation, and as you all know, our pop-up window is shown here. And in this in this file, we have to select the inputs. So I will select it one. This will be one, one, one. This will be let it be default. And if you want to change their electron temperature, energy cutoff value, exchange correlation, you can get it from here. There is a different type of exchange correlation value like LDGG. And if you want to change their equation control, you can get it from here. And basic set, if you wanted to change their Hubbard terms, if you wanted to get data into the Hubbard terms, you can uh, get it from here. Or if you wanted to change their spin type, like general spin or collinear spin, you can select it from here. Now we'll click on generate files, and there is a scf.input file is generated. Now if you wanted to see that input of the scf.input file, you can right click on the scf.input file and click open with. As you can all see, this is the scf.input file for your for this material. So now in this you can see there, this is the electron temperature, energy cutoff, exchange correlation value, and the k point samplings are shown here. And there is a no spin type is selected, and there is a mixing rate. And now if you wanted to change that some data into this, you can directly change data and click save. Now we have to calculate this scf.input file. So go to the scf.input file and right click on scf.input file and click run. So if you wanted to see this, if you wanted to, this is the run tab, in which if you have some parallel, if you wanted to calculate the parallel calculation, there is a codes are defined, and if you want, it goes up to for 32 codes. So click on run. Now when you click run, uh, their calculation is now running condition. As you can see, this is the status. In the job manager, you can see the status of your calculations. So now, in the meantime, we have to calculate the another parameters like band structure and Hessian matrix and phonon band structure. Like this type of calculation, we have to calculate it. So I will do it. So go to the build option, uh, go to the simulator option and click NanoDCAL and click analysis and take the band structure, action matrix and phonon band structure. Now we'll try to calculate the this values for this material. So we'll click on generate files. So now the file is the input files are created. Now if you wanted to see the status of your calculation, open with log.txt file. You can see your calculation is running condition. Now go to the band structure dot input file, open with and choose the parameters. These are the parameters, and in Hessian input, these are the file for input file for this Hessian input, and for band structure, phonon band structure, you can open it and see the data of input file. So now that method you can run the calculation. So I will go to the band structure dot input file and click run. Since the still the step dot input file is running, now another band structure file I run it, and this will come into the queue form, and I will calculate this for Hessian. So I will click on run. Now for phonon band structure, I will click on run. So all the calculations are calculated, and as you can all see, when you calculate the parameters, their output files are ready. Now we have to like we have to calculate it, the band structure ASEAN phonon band structure. I will also select the I was also selected the phonon density of state. So this type of things are their input files are calculate the result, and we will get the output like band structure. When if you wanted to see the visual interpretation, so go to the band structure, right click and click show view. So this is the band structure of this material. Now if you wanted to see this data into some specific ranges, you can type their data and get the ranges. Now this is the Fermi energy, and you can change their position of Fermi energy like top valence band, middle band gap, and bottom of a conductance band. You can change it the and Fermi energy. Now, if you wanted to export this data into the PNG file, so you can directly click on it and you will get the data into the image form. So now for the phonon band structure, we will click on show view. Now you can see this is the phonon band structure for this material, that is our graphene nano ribbon. Now this is the here you can also get the data from the specific ranges, and if you wanted to these are the things. Okay, this is the data between the phonon energy bit and the Brillouin zone path, and I will click, and if you wanted to see the phonon density of state, I will click on show view. Now this is the phonon density of state, and if you wanted to see data into the some specific ranges, you can type their values here, and we'll zoom it, and Now this density of state come from for this number of state and energy. So you can get the data from like this. So now that method, if you wanted to see this Hessian output, uh, so you have to go on the MATLAB. So we'll go to the MATLAB. If you wanted to see the data into the output form, so now I located the file where we are doing this project. So we have to locate it, and now you can see this is the dot mat files are generated for the calculation. So if you wanted to see the total energy, you can load it and type data. These are the raw data of your calculation. So type data, and this is the total energy of this material which we are calculated here. And this is, and now if you wanted to see the Hessian.mat file, load it and type data. Okay, this is the Hessian output for the your calculation. So if you wanted to see the specific data, you can type like data dot dynamic matrix. Like I will or I will click copy it, and I will this is dynamic. I click enter. You can see these are the data of your Hessian matrix, and like this method you can see the data as well. So if you wanted to see the data like Hessian matrix primitives, so you have to only select copy it, and or you can write it also and type data dot Hessian matrix slash primitive. So this is the displacement in which you can see the data like that method. You can also see the data from here. See, these are the data. See, these are the data for Hessian matrix of primitive. So by that method, you can calculate the all data. Like if you wanted to see the raw data of the raw output of density of states, so load it and type data. So now these are the values you can see here. Now if you wanted to see the band structure, I will load it and type data. Now these are the uh, raw output of your calculations. And if you wanted to see the band gap, take to type data dot band gap, click enter. See, this is the band gap of this of your material. So now that method you can simulate the material and get the output of this value. So thank you everyone to watching this video.